All right, good afternoon, everyone. Thank you for joining us for Unlocking Data, Strategies for Retrieving Insights from Hard to Reach Places. I'm your host, Nate Valentin, and with us today we have the great and powerful Director of Condition Monitoring himself, Mr. Nick Fiorini. The webinar is scheduled for an hour. It'll consist of mostly a presentation from Nick, followed by a question and answer section. If you have a question during the talk, you can just ask your question in the chat. If not, you can raise your hand at the end. I'll unmute you, and you can ask it that way. So with that, I'm going to turn it over to Nick.
Hey everyone, thanks for hopping on. I'll try to stop a few different times. If there are questions, Nate, feel free to let me know when a question pops up, and we'll build in some times for that. But I'm going to go through a bit of a presentation, jump back and forth to some different assets that help us identifying good fits for sensors location on an asset, and show you a bit of the platform, kind of what it looks like, the user experience, and then hopefully we'll have time for questions.
Right now you're showing your desktop.
All right, is it this one?
There we go.
All right, so you see this PowerPoint?
Yep.
All right, let's get started. All right, so the product we're focusing on today is called UrbanIO. It is a wireless condition-based monitoring solution that has some really long distance on coverage. There's a lot of different product offerings, so we're going to go through some of the common functions of these sensors, certain applications I've seen in the manufacturing sector, and a little bit about the technology and the fit itself. So this is a little bit of a solution map for different types of tier 1, tier 2, and tier 3 assets in manufacturing plants. And it's a good way to distinguish what is a good fit for hardwired condition monitoring that's being fed to a SCADA system versus maybe some IO link type components where you're getting condition monitoring, hardwired, sub-second sampling, and passing data to a PLC to make decisions. And then tier 3 assets, which are traditionally more on the fringe. They're ignored a little bit. You might check them on a quarterly basis by putting your hands on it, seeing if it's functioning with some high-end vibration equipment, stuff like that. So those are 3 different buckets of assets. Kind of tier 1 are the most critical. We're getting sub-millisecond or sub-second updates on the condition of the equipment. We're sending inputs to a PLC and outputs back to the controller to make decisions and do automated processes live. So those are tier 1 kind of SCADA assets that we're not going to focus on today. You probably, if you have condition monitoring in your facility, it's likely on those really critical assets. Tier 2, again, some big names would be Banner, Balluff, IFM, SICK, Pepperell, and Fuchs. These are more of the IO link type solutions where you have a little bit of control and you're still able to monitor these assets on a sub-second basis. But the layer of control is kind of what differentiates tier 2 from tier 3 assets. So tier 3 stuff, again, motors, fans, pumps, AC units, tank levels, different hydraulic applications, temp control panels. These are all the assets that are traditionally a little bit more ignored on the fringe, and you can't justify the cost of condition monitoring. So kind of starting from lowest to highest, that's giving you roughly $150 per point to monitor that asset in the field, kind of indoor or outdoor. The tier 2 assets jump up to $1,500 per point. That's because of the hardware that it takes to set that up, all of the labor that goes into integrating that with a PLC. So there's an NRE for some of that one-time upfront capability function, and then landing all those wires. So that takes time and hardware, so about $1,500. And then the 15,000 per point's the incredibly critical tier 1 stuff. In the US, we see a lot of Rockwell Automation, but the other big names are ABB, Siemens, and Honeywell. So we're going to focus on the screening sensors. I kind of think of it as like a hand raise. You know, if I have 1,000 different sensors across multiple facilities, and I want the data to guide my maintenance efforts, I want just a hand raise to say, hey, I'm operating kind of out of whack, I'm having an anomaly, come take a look at me, and guide your maintenance actions that way. So we're saying, what if it was less than 50 cents a day to monitor any of these fringe assets anywhere in the world, anywhere in a super remote area like mining, or inside and outside a manufacturing facility? So these are some examples of the sensors on some outdoor equipment. These are screenshots of what the software looks like, where you're able to visualize that data, trend it over time via your cell phone, your laptop, your computer. And that cost is really a big differentiator in how we're able to scale at different facilities. When you can be really low cost per point, it allows customers to monitor different parts of plants that they wouldn't have traditionally. And then this is a little bit of an overview. I can't see myself on the camera, but I'm holding a temperature sensor, same one that you see on the screen. So just so you could see a little bit of the fit form functionality of it. So they have a QR code on the top with an ID number. That is a unique identifier for each sensor. So I can scan a sensor and instantly pull up the data that you're seeing on your screen, which would be the way that we're going to look at this on our cell phones in the field. You can look at a graph of it over time and look at where the trend was going. You know, you can look at the last 365 days or the last 12 hours. And we'll go through a demo where we're going to look at it in the computer version, which has a lot more functionality. All right, so there are about 20 different sensor types. We're going to focus on the most common ones in the manufacturing sector today. I say they're all battery powered, and everyone asks, why are there cables hanging off of them? That's because some of these sensors either have a probe on the end, or if it's a current sensor, it would pair to a current clamp. So there are different accessories it may pair with to extract that data. But they are battery powered. They are IP67 rated, so waterproof, dustproof, and they have a field replaceable battery, which is included in the cost of the subscription. So if you have, you're reaching the end of the 2-year battery life, included in the cost of this subscription, which we'll get into the costing of it a little later, but all the hardware replacement. So if you break a sensor, we ship you a new one for free. Same thing goes for the batteries. As that battery is being drained, we can see an alert in the system and we'll ship you new batteries. It takes about 2 to 3 minutes to replace a battery. So they're all battery powered. They're taking that 2-minute or 10-minute heartbeat, I call it, but a sample every 10 minutes, and that's what's giving you that 2-year battery life. In certain scenarios, if we need to increase or decrease that heartbeat to sense a little bit more frequently or less frequently, that directly affects the battery life to, if you're sensing less frequently, you're increasing battery life and vice versa. So some of the most common sensors here on the far left, we have the ambient temperature sensor. I've put these in a lot of different server rooms at manufacturing facilities. Obviously, as the electronics fail in a server room, they're going to exhibit excess heat. That is a ambient temperature sensor. So this is going kind of in a industrial bracket like this here. You can slap that in here, magnetically attaches. This has double-sided tape backing, so I would peel this off, stick it on a wall, and that's going to give you inside of a panel or inside of a room the ambient temperature of that environment. Next one is a temperature probe. There are a few different versions of the temperature probe. The one you see on your screen has one cable coming off of it, so at the other end of that is a probe, and that is what we would typically epoxy onto a surface, like the bearing of a motor, or you want to get the contact temperature of a pipe or inside of a duct or cabinet. This gives you contact temperature as opposed to the other sensor doing ambient. There's also a multi-probe version with 3 different probes coming out, so you can get 3 different contact temperatures from one sensor. And being released very shortly is a high temp version with a type K thermocouple adapter. So we can do some really high temperature applications like steam. One of the most popular is the vibration sensor. We're getting triaxial vibration from this unit here. As all different rotating equipment starts failing, you're going to have different fault frequencies. We're going to vibrate, a little bit more often and at higher frequency bands. So this is a way of detecting that as a preventative measure. So we get horizontal, vertical, and axial vibration all from one sensor. Next, we have the on-off sensor. This is typically paired with looking for a relay output, so maybe a solid state relay, but any sort of alarm on an old piece of equipment that's not connected to a SCADA system. This is a great way of getting alerts, any sort of on-off or off to on type of signal that you'd like to monitor. This is always listening. So unlike some of the sensors that take a sample every 10 minutes, this one is always listening. And as soon as you see a change of state from off to on or on to off, you get an alert via text or email on your phone within about 10 to 20 seconds. So next up, we have a couple that are a little bit more paired for commercial real estate applications or facilities maintenance, but this is a light sensor. So it's a measurement of how much light there is in an area. So if you're doing any sort of agricultural applications like growing lettuce indoors and you want to get a measurement of light, this would be a good example of a sensor for that. A motion sensor, pretty self-explanatory. Is there motion or is there not? Very common during the COVID years in commercial real estate buildings when they needed to figure out how often to sanitize a conference room or clean a desk. But in manufacturing applications, we've looked at applications for how often are we servicing a machine or opening and closing a panel. A lot of different potential use cases for it. Humidity, very common for food and beverage manufacturing, where we need to determine the humidity level for potential mold growth. I've also put these into server rooms in manufacturing plants paired with the ambient temperature sensor so we can get a good idea of the conditioned air inside that cabinet to make sure the electronics do not fail. Then there's the moisture sensor. So this has a probe on the end of it, which is paired with aluminum tape. So you could extend the sensing range of that probe to cover up to 100 meters. And that is looking at basically the conductivity of the fluid between the two probes. So you could tell the difference between dry air, a little bit of dew, and a drop of water. And we're looking at potential applications, testing this on oil cleanliness, where we could determine how much water is in the oil. There's another sensor that has an analog input, and there are other manufacturers that make like a parts per million counter for water inside of hydraulic systems. So we're looking at different ways of doing some hydraulic reliability with these sensors as well. So bring those ideas to us. If you have good ideas to test them, we're happy to do that and put together some case studies. Meter count sensor. This is a utility consumption sensor. So it's paired with a water meter or electricity meter. And we're using this to always listen, it's always listening and counting. And it's paired to a smart meter that will pulse per unit of consumption. So for, electricity in kilowatts per hour, it's going to have a certain number of pulses over 10 minutes. And we're going to count all of those pulses. And then the 10-minute interval, pipe that data upstream to the gateway and up to the cloud. Then we have an activity sensor. This is an actual measurement of activity in a room at a given time. So this has a bunch of different infrared beams coming out at different angles, and it's got a 5-meter kind of dome that it covers, and it's looking for how many of those beams are broken at the 10-minute sample rate, and that is a measurement of activity in an area. One of the more popular ones is a current sensor. So this is paired with this current transducer here. So we would take, say it's a 3-phase motor, We would take one leg of that power, run it through this current transducer. This converts it from AC to DC. And on the end of the current sensor, we put the probes here on the positive and negative, convert that to DC so we could get an amperage reading on any sort of electric motor or fan or pump or blower. If you have smaller assets and you're looking to monitor, under 10 horsepower type motors and pumps and fans, then I would likely recommend just doing a current sensor. It might be overkill if we did vibration or temperature on the bearings. And current's just a very easy way to see when we have anomalous behavior on current, that's an indication that something is failing. So it's a very popular one. It can be used in conjunction with other sensors to get full model health of larger pieces of equipment, or on smaller stuff, it's a great solution to just say, hey, it's a small piece of equipment. Let's just monitor the current on this. That gives us enough information to know if this thing's going to fail or not. All right, then we have the process loop sensor that is looking for an analog input for any device, and it's going to tap into that analog input and pull it out wirelessly. So we can look at flow rates, say of flow meters from our phone or from the comfort of our desk on our laptop. So any sort of like 4 to 20 milliamp output from an existing device, this is a great way to retrofit onto that device and pull the data out wirelessly without having to add equipment to monitor that. 3 different types of pressure sensors. So we have differential pressure, vacuum, and wet dry pressure. DP is really common in HVAC systems to determine when do we need to change the filters. We've actually added DP sensors to a lot of bag houses for dust collection. So if we have pulse valves firing air and blasting dust off of these filter bags, and we need to determine when to fire the pulse valves based off of DP or when to change out the filter bags, then this is a great solution for a retrofit part of our dust collection kit monitoring solution. So we have a bunch of different sensors that go into that, but we've done DP on HVAC, we've done it on bag houses, we've done it on filters for a car wash, vacuum filters, stuff like that. Vacuum pressure, very self-explanatory. Do you have a process where you need to maintain a certain level of vacuum pressure? And we can tap into different points across a larger system and look for vacuum pressure drops to determine the root cause of that and locate the source. Then we have wet dry pressure. So that could be, it's paired to a pressure transducer, which I have one on my desk here. And that transducer can go to a gas, any sort of air, fluid, hydraulic oil. This particular transducer is for 0 to 145 PSI. So if you have different applications for higher pressure, or if we need a more sensitive lower pressure transducer, there's a bunch of different accessory options. We just need to know what we're sensing so we can pair it with the correct transducer. Then there's the battery test sensor. So this is used very commonly in mining, but a lot of applications that are remote and have motor starters that are battery powered or backup generators, and we need to test the battery in that backup system to make sure it has enough juice when it's needed to turn something on. So these are kind of an overview of the most common sensor types. There are a few more. Bring your applications to your Adams territory rep or to me directly, and we could see which application is the right fit for this or that type of asset. Nate, any questions in the chat so far, just based on the product breadth that we talked about?
No, right now we don't have any open questions.
All right, sounds good. So I'm going to keep buzzing through this presentation. Again, type in any questions you have, and it all starts to make more sense once we get into the demo and show you a live use case of this. So you have all these different options for sensors to monitor different types of equipment inside your plant or outside your plant. And all of those sensors are sending their data to these 2 types of gateways. On the left side of the screen, we have an indoor rated gateway, so that is IP65. On the right side, if you have outdoor applications, this is more of a solar powered outdoor gateway with an IP69 enclosure and up to 6 days of battery backup. So we'll determine based on our initial site survey, where are you going to mount that gateway? If you're outdoors, but in a, maybe on the mezzanine or on the roof of a facility, we don't need this whole solar powered option. We just manufacture an enclosure that goes around the indoor gateway so it can be IP67 rated. So we have multiple different options, not much of a price delta, but just depends where this gateway is going to be mounted in your facility, so we can collect all of these data, or all of this data, from the range of sensors. And the big differentiator on this gateway technology is the sensing range you get. So unlike Wi-Fi and Bluetooth that have a mesh network or a multitude of different gateways dispersed at a facility to get enough coverage, this is a solution that gives you 500-meter indoor range or up to 3.12-mile outdoor range in a radius, so you can deploy less gateways to connect to more devices across a large campus, for example. So it's called LoRa technology. It's a private LoRa network. So this is on a separate network. We're not tying into on-site, on-prem equipment like a Wi-Fi, which makes the cybersecurity guys really happy. So from an IT standpoint, we're on a separate network and we completely manage that network. The gateway auto connects to 540 different mobile network providers. So we'll get service anywhere in the world. And if it's a really remote application where we can't get any cell service, we could also pair these directly to Starlink satellites and get the data up to the satellites that way. The unit on the left is much more common. This is what we use for most of these manufacturing facilities, and that one has 30 hours of battery backup as well. So in Florida, where we've done a lot of these installs and you lose power quite often in the summer during the storms, our sensors are battery powered and the gateway has battery backup, so our system will always be up and running. All right, so this is kind of a preview of what the demo is going to look like. So you have this web browser platform, and you could pull this up on your phone, your laptop, and you could see the data for the sensors on the left side of your screen. And on the right side of the screen, you can look at this data with location capabilities, either on a 2D map, which is built into the platform at no additional cost, or a 3D map, which is what this GIF is showing on the right side of the screen, where it is an actual image like the Google Street View of your site with your assets on it. And we import the digital graphic for the sensor icon right above the physical sensor. So you could click on the icon or click on the left side and pull up the live data for that device. So if you did want what we call this digital twin, there's a video that I'll show shortly that kind of highlights what that looks like. But that's about $3.50 a month for any assets that you'd want to have 3D monitoring on. And the sensors, if you want all of the sensor data, the hardware, the software, the 2D viewing of this platform, that's the base cost of this, and that's $15 a month. We have another slide that'll get a little further into the pricing structure, but those are kind of your two different options. So this is saying when we only have one gateway that could service a large campus like this, we're able to get a cost-effective solution to monitor dust collection, bucket elevators, HVAC equipment maybe on the roof, all of those really hard to access fringe assets in your facility that you don't typically walk by and put a hand on 5 times a day. We're able to take a 10-minute heartbeat and sample them over time and then get email or text message alerts based on a profile that we set up for that asset, and let you kind of sit back in your chair and not have to do this routine walk every day to go monitor those assets. So I'm going to jump into a live demonstration of what it looks like inside the platform. All right, so this is Google Maps embedded. So as I zoom out, I can see some different customers in the Tampa Bay area. As I zoom in a little more, it switches from purple to satellite view. And then as I get closer to the facility, you can see that roof changes And this is part of the relationship that Adam's team has with the customer to say, this is what we need from you to get your platform to look as user-friendly as it could possibly be. And we're going to come in and name all of these assets with your names, mount them on your equipment, and then give you this 2D dashboard to navigate around your facility and locate a sensor that's having some sort of issue. So on the right side of my screen, on the floor plan, we've imported their 2D floor plan. There are two different levels. So we have the first floor and the roof. So on the first floor, we have, maybe 75 different sensors on a few different lines. They're color coded, so we could see this line's having a bit more problems right now. I could click on an individual sensor. This is a vibration sensor, and it's going to pull up the data for that device. It's going to show me the profiles for what is good, what is bad. Right now we're looking at the network profiles. So this is the battery and the signal strength to the gateways. So we could set up alerts for those network issues. If the battery's getting too low or if the connectivity from my sensor to the gateway is dropping, I want to know that so I know if I'm getting live data. And then these are the status alerts. So this is the profile that we've created for this vibration sensor on this motor. If it's off, it's color-coded blue. If it's on and it's vibrating in a healthy state, it's green. If it's vibrating a little harder than it normally does, we call that review. That's something we might want to send maintenance out to take a look at, just make sure there's no critical issues. And then we have check. That's vibrating harder than it typically should. So we've set kind of like a warning limit. That's going to send you an email or a text message, as well as issue. That's our critical issue. We're vibrating between 8 and 40 millimeters per second. That sort of velocity is indicating that there's some real failure in the motor. So we need to get out there, replace it, and order some spare parts before it's too late and we've caused unnecessary downtime. So I can go back to my data streams. This is a vibration sensor, so I have axial velocity, vertical, and horizontal. I could see that each of these axes are absolutely maxing out our vibration velocity every few readings. That's a really bad sign. So I probably want to say over the last 12 hours, it's maxing out. But if we zoom out and look at the last year, what's been the trend of this asset since we started monitoring this stuff in early June of 2023? Has it always vibrated this hard, or is this a new occurrence and this is indicating failure? And as we can see here, when we installed it back in early June, it had some spikes where it was going a little bit higher, but the general trend of this asset is going from, over the course of almost 9 months, we're going from our average being around 2 to 4 millimeters per second of vibration on the axial to spiking over this last month here to 10 millimeters. And I can say combine axial, vertical, and horizontal charts together so I can look at the average of each of those axes and see that this is a really bad sign. We were kind of living in this, the trend was going up, but if we did some sort of lubrication or replaced a bearing, this would level out. Something's starting to fail, and it's probably pretty critical because it's now spiking over the last month or so. So we keep up to 365 days of data trending inside the platform. And then after 1 year, it's then stored in cold storage. So we'll always store the data for you. If it's more than a year ago, then you just have to email your Adams rep and say, hey, I want to compare LMC S1 outfeed vacuum, the non-drive end vibration to this time last year. And we'll email you that information. But we have the ability to filter the data, look at the last 60 minutes, the last up to a year, combine the charts so we could put them all on one chart and look at 3 different data streams. If I had multiple sensors and I would compare that data all on one chart, I could add different devices as well. And I can navigate by clicking on the icons on this side of the screen, or if I kind of scroll through and look at something that's interesting, like in the boiler room, this HPR pump is looking pretty hot. If I click on that, it's going to zoom my 2D map so that this sensor's in the center of it, and it's going to flash that icon for me. So the whole 2D version of this platform gives the maintenance team a naming convention. So if they, we're using your name. So the customer said, we call this our boiler HPR pump 2. So that naming convention gives you hopefully enough location to say, I know where that is. If not, as soon as you click on the sensor icon, it's going to locate it inside of your plant and show you this is where that specific sensor is. This is where it was mounted. This is where it's installed. Go to that location. So if you have a lot of labor turnover on the maintenance team, this is a quick double check to get them quickly to go see the issue at hand. I can filter by sensor type right here. So if I want to say, hey, pull up all of my vibration sensors, just going to click this, and it's going to filter to all of my vibration. Then I could find the one that's red and it's interesting and do some more analysis on it. I could also filter here by alphabetical, so reverse or A to Z. And we're about halfway through. So are there any questions so far in the chat, Nate?
There is a question. So the distance for sensor to gateway seems to be impressive. What is the impact caused by steel and structures and other equipment? A densely populated plant would limit distances, ?
Great question. So when I say 500 meters of range, that is in a radius from that gateway, assuming some obstructions, but not like big metal cages or walls or anything like that. So if you have a very dense plant with a lot of metal, then we're probably going to see a reduction in the sensing range of our gateway. That leads me into the point of something I want to touch on anyway, that every 30 sensors justifies a free gateway. So we can do a facility this size that you're seeing on the screen, which is a large cardboard facility. We could do this with one gateway, no problem, but they have 100 sensors, so that justifies at least 3 gateways. So I'll probably bring 2 gateways on site for the install, maybe all 3, just in case we need it due to a lot of metal in the way. But if we have a lot of, just slabs of cement, walls like that separating rooms, that's not as big of a hindrance as metal. So it reduces our range. Basically, if you put the gateway in a metal box, that's going to cut the sensing range in half. But if you have some metal structures in a facility, the network tries to work around that, but it is eventually limiting us a little bit. But every 30 sensors justifies a new gateway. So if you have 100 sensors on site, some facilities might need 3 gateways, some might need 1.
So Nick, would it be safe to say that multiple gateways would be the solution to a densely populated heavy steel plant?
Yeah, that would be the case. That's all part of what we like, the upfront work that we should do together. Kind of a good time to talk about this, but customers interested, we bring up this example. Hey, I have a dense facility. I'd love to get you on site to look at what are the assets we want to monitor and where do we want to mount that gateway. So that's the practice I would recommend with proceeding. If you've had interest, you've identified some good monitoring points across a facility, get our team on site to do a survey. Because what we're going to do is we're going to document the assets that you want to monitor. Hopefully, if we can take pictures of them, that's a big help as well. And then we're going to spend some time figuring out what is the sensor mix that we need to provide to give you the health of those assets you've identified as a good fit. And then we'll have a ballpark view of how many sensors we need. Let's say it's 50, for example. So we could say, all right, 50 sensors, we could bring 1 gateway on site. If it's a really dense application and we see the need that there's going to be 2 gateways, if you had 60 sensors, that would justify the cost of 2 gateways. Are there 10 other things we might want to monitor? Yes, great. So we'll do 60 sensors, 2 gateways, And then we'll identify a good location on site to mount those gateways to get coverage to all those different devices.
And then, Nick, if I remember correctly, one of the first couple installs that we did, you were actually actively monitoring for connectivity from the gateway to all of the sensors. In the event that there might be connectivity issues with some of the fringe assets, you could always go back and install another gateway. Is that correct?
Yep, that's why we have an extra one. So we set up the gateway at the main point that we think is best, and then we range test. So we go to all these different assets. Typically, I'm going to find the furthest away sensor from that gateway with the most obstruction. So maybe the most metal between it and the gateway. And I go to that gateway and I turn it on and I do a range test. So I could see in my platform, what is my signal strength at this sensor? And if it's above my weakest threshold, then I know I'm probably good at a lot of these other points, but we still do a range test every sensor we set up. So I have this device here, which is a little bit of a crude range tester, but something that I use on site during installs. And any sensor that I turn on, I can range test as well.
All right. Well,
So
we've got another question that just popped into the chat. How is the current monitor used to reduce energy consumption? Do you send specific suggestions to clients?
To reduce energy consumption, that's a good question. I don't have the answer to right now, but we're going to monitor energy consumption. So it comes back to what is the goal or the purpose of your inspection. If you want to do like machine runtime, which is a common application, there are multiple ways we could do that with an on-off sensor, with like a relay output if it turns on and off, or if we monitor current consumption over time, we could indicate how often are we running and do we need to be running at times where, you know, this machine's not critical. Like, can we turn it on and off? Is that more efficient than leaving it on? But the main purpose of our solution is to wirelessly transmit that data and allow you to make decisions with it. So a lot of times what we're putting a current sensor onto a motor for is to indicate that it's failing. So look for anomalies. Like if it's failing and we're seeing a current spike, that's our indication of failure. So come fix the problem. There's a wide range of other applications you could do by monitoring current, but our solution trends that data over time and you're enabled to make decisions with it as you see fit.
Got it. That's all we have for open questions right now, Nick, if you want to keep going.
All right, cool. So I have a couple different videos that I want to share. One shows the digital twin, which is our 3D platform. One shows another new feature that I will be rolling out in about a month. So that might be another follow-up presentation. If you have interest in this technology, your best means of getting kind of hands-on with it would be to contact your territory rep. Every one of them has a demo kit with 10 sensors and a gateway. So they could take it out to you and do a demo, put it on some of your equipment, potentially do a 1 month, 2 month trial, which we do as well. So if you want to test it out, feel free to do that. And then these two videos will walk you through, if we do a full setup with 3D and digital twins, this is what the capabilities we'll have here. And I just realized I'm sharing the wrong screen. So let me fix that.
Yeah, we still see the dashboard.
All right. I want to show this one first.
There we go.
All right. Skip ahead because I already showed you what 2D looks like. This is 3D. It's live in the platform. It's down right now as we're doing an upgrade to the API key that ties it into this other software that we use to do the floor plan with. But essentially, you're getting the same data. You're just seeing it in a 3D platform that you see on the screen here. So, like I said before, I call this Google Street View. The other view is like the Google Map View. Google, if you're using Google Maps, it's what it looks like in satellite view. So this is something where I would take, you know, this is the roof of this cardboard facility. So nothing proprietary up here that they cared about. They said, feel free to do 3D. And this will be, you know, there's about 20 different sensors up here. So you would only pay the additional 3D cost on these 20 sensors. I take an image with this 3D tripod that I have, and every 5 meters, I take a new picture. And then what we do on the back end is we tie this into your 2D floor plan. And within about an hour or two of fine tuning it, we'll take those sensor icons, move them over the 3D image. And when you click on a sensor on the left side of your screen, it'll pivot the whole view in 3D. So it's looking directly at our sensor in the field. Pretty self-explanatory. There's 2D and 3D. The other really cool new feature that's being rolled out, this would be, I was kind of getting to it, but it's coming out in about a month. So right now, get hands-on with our salespeople, have them bring demos to you, and then within about 30 days, I'll have a live demo of this version of the platform. So I'd be happy to walk you through it. This is called BI reporting. And what you're going to see in this use case is a utility consumption dashboard. So this is it's called, it's like a cloud kitchen base in the UK, United Kingdom. So it's about 200 different restaurant pods for to-go food, and they are monitoring hot water, cold water, electricity, and gas consumption of each kitchen pod, and they're going to compare at certain times of day, compare that kitchen pod to all other kitchen pods, and look for anomalies in utility consumption to indicate some sort of issue. So you could say Five Guys, for example, if there's 15 different Five Guys kitchens across the UK, we could compare at noon on Monday for each individual pod how much hot water, cold water, electricity, and gas is each pod consuming. And if one of them is consuming far more than the others, you're going to receive an anomaly in the platform. And that anomaly is going to allow you to kind of identify the needle in the haystack for which location is doing something incorrectly. Or to apply this to rotating equipment, which motor or pump is vibrating the hardest or seeing the most deviation from its threshold for healthy. So we can now tell maintenance, I got a report based on 100 or 1,000 different motors. The ones with the worst health score are pulled to the top, and they allow you to identify where to focus the maintenance efforts. So in utility consumption, it's going to be look for anomalies. Maybe someone left the hot water on overnight and we just burned X amount of energy. That's an easy anomaly to fix. Or maybe we have a leak somewhere, or maybe, this kitchen is run inefficiently. Whatever it is we're identifying the anomalies across large data sets to give information to the user so they can take action without having to filter through this data manually. So it's called IoT BI reporting. It is available for utility consumption now, and in about a month, we have a dashboard coming out where we use your naming convention paired with our naming convention, and our naming convention is what allows these reports to pull in data. So if your name is LMC machine 2, we're going to add dash MDVE, which would be motor drive and vibration if it's a vibration sensor on a motor, or maybe call it fan MDE. And our acronyms on the end pull it up so you can filter by, on my rotating pieces of equipment, I have motors and pumps and fans. I want to filter by all of my motors or fans or pumps and allow them to compare themselves to other motors or fans over time and compare it against itself over time and say, I'm deviating from norm, my health score is going up, and I need to have someone come take a look at me, so send an alert to the platform. Hopefully that's making sense without having a live version of it to demo right now. But I'm going to kind of skip ahead to this version of the vibration report to help you understand what this looks like. So over time, if this is a vibration sensor and each of these slices is a month, we could say in month 1 and 2, all of our readings for vibration fell within the healthy threshold. This sensor has a 0% health score, which is perfect. In months 3 and 4, we're starting to see the frequency and the elevation of these bands increasing. So our health score is getting worse. So maybe it's a 30 or a 40 now. And if you kind of look ahead towards month 6 or 7, we're seeing the magnitude and frequency of these vibration readings occurring more often, happening at a higher frequency. So that is making the health score more close to 100, which is our worst score. So this is giving alerts now via text and email to maintenance to come take a look at me. So that's a version, like on the far right of the screen is 100% health score, far left would be 0. And that's how we identify anomalies and give them that score. So you can go filter through all of those different asset types, look at the score, and identify where to focus your efforts. This is a version, a screenshot of what it looks like for that cloud kitchen pod. So basically, these are some really bad anomalies. We're saying at multiple locations across the UK, you know, these 5, 6, 7 kitchens are seeing big anomalies from what's normally consumed on these utilities. So let's go take some action now. Before I sum it up, what do we have? Perfect, a few more minutes. So these are different deployment guides. This is kind of what I want to use to enable you guys to say, these are my common assets. Where would we put sensors on these? So we have some templates that we've put together to identify if you want to put vibration and temperature probes on a motor, where are we going to mount them so we can get the right data? So on a motor or a fan, these are the 3 common sensors we use: current sensing in the electrical box, vibration sensors. If you have only one vibration sensor on a motor, you want to put that on the motor drive end. So we're getting as close to the shaft as we can. If you have 2 vibration sensors, then we want to do the motor drive end, MDE vibration, and the NDE, the non-drive end or the butt of the motor. That way we could get progressive shaft imbalance. If they're vibrating at different speeds, we'll get different frequency peaks. And then if you're going to do a temperature probe to get that bearing temperature, we want to put that on the bearing. And typically that there's only one spot on a motor we would monitor. So if you're doing the full model health of a motor, we would do potentially 1 temperature probe, 2 vibration sensors, and a current sensor. And then what is that motor coupled to? We have belt drives, gearboxes, a lot of different options, but whatever it's connected to, if it's a direct drive fan, 1 vibration sensor for the fan, that vibration sensor is going to have a custom profile. Since a fan's going to have higher axial vibration just in how a fan works, we're going to have a custom axial profile for the fan. And if horizontal and vertical also experience high vibration above their threshold, then that's an indication of fan failure. Same goes for vibration on the belt drive coupling, fan drive coupling, gear drive coupling, or whatever else the fan, the motor is coupled to. That's another point that we can monitor vibration. Same concept for a pump. I don't want to spend too much time on that. Going to skip ahead to one that we've done that has a lot of different potential points on it. This is a dust collector. So in dust collection, this is everything we could supply if we were going to do it perfectly, but we have pre-filter and post-filter pressure sensors to calculate DP. We have on and off sensors to count pulses from the pulse valve controller to those banks of pulse valves. There's options for a meter count sensor to go with a flow meter for airflow consumption. Then we have on the motor that's generating the vacuum, we have vibration on the non-drive end and the drive end, temperature probe on the bearing on that motor, and then the motor is paired to a belt drive that is connected to a fan. So we're monitoring vibration on the belt drive as well as the fan, and then current inside of the junction box as well. So there's actually a humidity sensor that we didn't install at this customer, but if you want to get the humidity of that air, that's going to affect your pulses as well. But this is something I would recommend doing, especially if you're looking at swapping from, say, a diaphragm style valve to a spool style valve from Mac valves. You can do a efficiency study maybe before and after the Mac valve upgrade to help you justify rolling out this solution at other bag houses. So it's going to get you the full model health and efficiency of that dust collection system. So this is an example of a deployment guide. Where do we put those sensors? What are the naming conventions we add onto your name to help pull these into our automated reports? So we'll have an automated report for a dust collector. We'll have one for motors or pumps or fans or blowers. We have utility consumption dashboards. And we'll build dashboards based on your needs. So if you say, hey, I have a batch process or some sort of process that a dashboard would work great for me, but I also know there's probably millions of other customers that would benefit from this. If you have volume behind it and a justification that it would work for other partners, we'll definitely provide resources to do that the fastest. But now that these BI dashboards are now complete, one exists and more are rolling out, we're able to adapt them quicker now that the backend algorithms are done for new applications, new industries, and new needs. So I'm the head of sales here in the US. If you have these needs, you see there's an industry or an application that this would benefit, bring that to me. Same goes for any type of sensors. If you see we could adapt a sensor to fit a need that applies to me or potentially applies to the industry, we can manufacture a new version of the sensor very quickly, within about 3 to 6 months, and we're happy to do testing with you. So we can be flexible. I definitely appreciate feedback on where you would find more benefit from this technology, but today's outline was to identify the hardware, the capabilities, some common applications, and then the main follow-ups from this would be with your direct reps to say, let's come on site and do a site survey, look across our different assets. What would you recommend? What causes downtime for you guys? That's a pain in the butt, and you would love to have data to feed you insights to it before it breaks. Then we'll do that site survey, collect a bill of materials, get you quoted, do an install as fast as possible, and train your team on how to make this platform work for you. So any other questions, Nate, on the Teams chat for now?
So one thing that came up is, are there any industries specifically, Nick, that this technology you feel like has stood out to you?
Any industry specifically?
Yeah.
Man, the kind of the beauty of this technology is that it can be very industry agnostic in terms of everyone has fringe assets at their sites that they don't monitor. Having said that, we've done quite a bit in certain industries, in the US specifically, kind of food and beverage manufacturing, where maybe you have a canning process and the cost of downtime when you're making, potentially thousands of cans a minute, when you have super critical processes where downtime is very critical or costly, that's a great fit for monitoring fringe stuff you didn't monitor before. So we've done that. We've done dust collection, which applies across a lot of different industries. We have done mining. Mining is a big one in other parts of the world. Those are very remote, kind of spread out campuses of equipment, very high cost assets. And when you have locations that are outdoor and spread across large locations, it's really a no-brainer. There's not many other technologies that have 3-mile radiuses from the gateway. So that's a really good fit. Other than that, really, we're bringing this into manufacturing. So there's a lot of needs, I would say, anywhere with a mix of old and new equipment where everything's not connected. That's a really good fit for UrbanIO.
If you have any questions, feel free to raise your hand, put them in the chat. I just put Nick's email address into the group chat. Just a few housekeeping things from us. You will receive a recording of this presentation. We will also be following up with all of you directly. So if there are no other questions, we just want to say thank you all for your time. We really appreciate the questions.
One more thing, Nate.
Yeah.
I just thought of it, and it's an important one because it comes up quite a bit in meetings with customers too. We have APIs configured now, so we can pipe the data from UrbanIO's platform out to other cloud platforms. So if you're already using like AWS or SAP or Azure, Tableau, IBM, any of those platforms, our sensors can be the means of collecting this data from these fringe assets and pipe it into another platform that you're already using for free. I just wanted to mention that because it comes up a lot, you know, CMMSs. So customers have these CMMS softwares and they're like, can your sensor feed us places, you know, feed us data so we know when to order replacement parts? And the answer is yes.
All right, good point. Good point, Nick. And with that, I don't see any other questions. So again, thank you all for joining. Nick, thank you. You did a fantastic job. And we look forward to working with you all in the future.
Thank you all. Again, reach out with any questions, but hopefully this is an exciting technology for you and can open up some doors into getting data and these things that you never thought were feasible before.
All right. Thank you.
Thank you.